welcome to section 4.2.5. This was the last section in chapter 4, and we chose to do this section. It really basically requires you to do a lot of thought. It's a very rich problem, and the basis of the story problem they give us here is the students decided to do a prank at a school, and so they stole a trophy. And the groundskeeper, Millie, saw the student who was stealing the trophy, but basically could only identify them by that they had red hair. And so here's some of the things that are going to happen in the story. Reading it, of course, is going to be better, but as we read along, we find out that she knew that we know that there are 100 students in the school, and that the one that she saw had red hair, and only the 5 measly children have red hair. And so we know that that's that number. And so the headmaster decides he's going to take Millie out. She's the custodian who saw it. And give her a little test to see how well she identifies hair. And so when she does that, she identified it correctly, the hair color correctly, 4 out of 5 times. And so we've got a situation where we either want to do a tree diagram, or we want to do an area model to kind of look at how this is, what the probabilities are. Because you're going to try to defend her and be able to use some probabilities to say that one of the measly kids, is innocent or guilty. So I'll bring this back as we need it, but I'm going to use an area model. And so in my area model, I'm kind of thinking 2 ideas. The 2 big pieces of information that we know are, we know hair color is important. And so there's some students at the school that have red hair, and we don't really care what the other colors are other than the fact that they are not red. So 5 out of the 100 students have red hair, and 95 out of the 100 don't have red. So we have 2 columns here. Then I'm kind of interested in the experiment we did with Millie and her observations. She was either correct or she was not correct. And if we kind of think about that, breaks it up this way. She was correct 4 out of 5 times. Let's see, that would leave us 1 out of 5 times that she was wrong or not correct. I'm going to put in here really quick what these mean. This is the box where if somebody with red hair walked by, she was right. So she would say that it's red, and she was correct. Here, somebody without red comes by, and she was correct. Here, somebody with red hair came by, but she was not correct. And if she was not correct, she said that it was not red, and thus she was. And here she said it was red, and she was, I'm sorry, I was using the word not correct instead of incorrect. Okay, now I'm ready to put my numbers in here. Just a quick reminder of how we calculate that. This is going to be 4/5 times 5 100ths, which is going to be 20 500ths. This one is going to be 4/5 times 95 100ths, which is 380 500ths. This one is 1/5 times 5 100ths, or 5 500ths. And this one is 1/5 times 95 100ths, or 95 500ths. Okay, I'm going to try to use a color you'll be able to see. So we're going to use red real quick, and we're going to talk about what these percentages are. If I calculate this percentage on my calculator, I'm going to find that this is 4%. That's what 20 divided by 500. Change it to a percentage. This one's going to be 76%. This one's going to be 1%. And this is going to be 19%. Well, let's think about what that means. A percent is basically out of 100. So in the question 89, we've modeled it. So here's some questions they'd like us to think about. It says, suppose that to help make Don's case, you perform the following experiment repeatedly. You pick a student at random, show the student to Millie late at night, and see what Millie says about the student's hair color. If you perform this experiment with 100 students, how many times would you expect Millie to say that the students had red hair? Well, let's look. She said they had red hair here, and she said they had red hair here, even though she was not correct. So I would expect her to say that they had red hair. Millie say red. 4% plus 19%, or 23% of the time. Now, next question. If you perform this experiment with 100 students, how many times would you expect Millie to say the students had red hair and be correct about it? Well, the only time she's going to say red and be correct is this 4%. So on this next part, we're going to say she's correct, only 4%. When she's doing that. If you perform this experiment with 100 students, what percentage of the students did Millie say had red hair would actually have red hair? Well, this is how many actually had red hair. This is how many she said. So it's going to be basically 4 out of 23, or approximately 17% of the time. Okay. Can you use these calculations to defend the Measleys? Is it likely that the Measleys were the thief? I'm not sure we can tell whether the Measleys were the thief from this information, but it is kind of interesting that by using the probability, if we just go by how often she's correct, we would say she's correct 80% of the time. That's how often she gets the hair color right. But how often does she get the red hair color right? Well, she only gets red hair color right 17% of the time. And so there's some argument that we can make to say that, this really, she's only going to get it right 17% of the time. So actually about the other 83% of the time, she's going to be wrong about a person having red hair color. And so that is our argument. I hope this helps. This was really rich and we kind of went through it pretty fast. But I wanted you to see how this problem and how we kind of developed it and put it together. Good luck.